Today, we will be talking about square roots and real numbers. A number n is a square root of a number b if n squared equals b. Example, 7 squared equals 49. So 7 is the square root of 49. When you write a square root, there are two pieces. There is the square root symbol, called a radical, and the number underneath, called the radicand. We are going to evaluate 3 examples for square roots. Example number 1 is the square root of 36. Because we know that 6 times 6 equals 36, we know the square root of 36 is 6. Example number 2. We know that 8 times 8 equals 64. Therefore, the square root of 64 is 8. The third example is the square root of 121. 11 times 11 equals 121. Therefore, the square root of 121 is 11. Those were all examples of perfect squares. Sometimes you have to estimate a square root because it is not a perfect square. There are 3 steps. Step 1. Identify what 2 perfect squares the radicand is between. Step 2. Find the square roots of the perfect squares. Step 3. Write your estimate. Here are 4 examples. Example number 1 is the square root of 15. Thinking about the number 15, the closest perfect squares would be 9 and 16. The square root of 9 is 3. The square root of 16 is 4. Because 15 is closer to 16, we would estimate the square root of 15 to be about 3.8. Example number 2, the square root of 60. "60 sits between 2 perfect squares that are 49 and 64. The square root of 49 is 7, and the square root of 64 is 8. Because 60 is closer to 64, we would estimate the square root of 60 to be approximately 7.7. Third example, the square root of 5. 5 is closest to the perfect squares of 4 and 9. The square root of 4 is 2, and the square root of 9 is 3. Because 5 is closer to 4, we would estimate the square root of 5 to be about 2.2. Example number 4. The square root of 23 has a square root that sits between 2 perfect squares. 23 sits between 16 and 25. The square root of 16 is 4, and the square root of 25 is 5. Because 23 is closer to 25, the square root of 23 can be estimated to be approximately 4.8.